Okay guys, this is a new and revised rendition of my planets, the orbit of the planets within the concave Earth. This actually makes perfect sense. It's functional. The retrograde motions are all working in fluid motion harmoniously with the magnetism of the Sun. When the planet goes opposite the Sun on the other side of the celestial sphere, it gets magnetically confused, it loses its magnetic influence from the Sun, and goes the other way. It starts to sag, it starts to get lower to the Earth, so the angular diameter increases. It also increases its brightness. The magnitude is measured by the lower the number makes it a brighter object in the sky. So during the retrograde, the planets are going to become bigger. The angular diameter is going to get bigger, and they're also going to become brighter. There is an antipolar, anti-solar illumination zone opposite the Sun. That's how we get full moons, because the sunlight is bending around the other side of the Earth. It's using the glass sky to curve around like that, and it meets it. It converges there. That's how we get lunar eclipses too. There's actually a funnel-shaped void area there. If you can see that, a faint little dark line there. But when the planets are opposite the Sun like that, that's how they get their retrograde motion, because they're losing that magnetic influence. This is a top-down view. It's orthogonal. It's not showing the tilt of the Sun. I'm just doing a straight going around like that. It doesn't have the actual 23.4 degree tilt, which would make the planets look a little bit different too. So we have different planets here. I actually mapped out Mars. I plotted it out, so I show the different magnitude each day. See, each frame here is a day. It's not, you might think that, well, the Sun is going the other way. No, that's because I kept the celestial sphere stationary. And so then that way I use that as a frame of reference to have all the other objects moving around it. So each frame constitutes one day. It's not 24 hours going on around like that. It's actually just one frame is one day. And so the Sun appears to be going the other direction, but that's only because the celestial sphere is not moving. Now remember, before I said that the celestial sphere is 23 hours and 56 minutes and 4 seconds. And so the superior planets, which include Neptune, Uranus, Jupiter, and Saturn, they are going to be more in sync with the celestial sphere. They're not going to appear to move as much with using the celestial sphere as a reference. So Neptune would be the planet with the least amount of movement, that little blue dot there in the bottom. Then Uranus, that other blue dot on the bottom left. Then Saturn's up at the top right, and then Jupiter's on the left-hand side. So you see the loops. I included the paths. You see the retrograde paths. Each year, those planets are going to do a retrograde because of the Sun. And then you have Venus. Venus is that green path. It's doing a retrograde there on the bottom right. For about 6 weeks out of the year, it's going to do a retrograde like that. Then you have that white line is Mercury. Mercury zips around, kind of like a fly around a horse. It just zips around the Sun like that. It does a retrograde 3 times a year. So this whole cycle is actually taken as, I used Mars as a reference. So Mars actually goes around, it passes the Sun about once every 2 years, a little bit more than that. So I actually plotted out Mars, a different magnitude and the diameter, and I show that when it goes into retrograde, Mars is that orange line. When it goes into retrograde like that, it's going to get bigger, and it's going to get brighter on the opposite side of the Sun. And the glass sky is used, the refraction. See, this is also, I approximated the distance, so I couldn't really tell, but I just went by the angular diameter, and I just approximated how far away I thought they would be going, with the inclusion of looking through them with a glass sky that actually exaggerates the size, the scale. If you get closer, if you get farther away, kind of like a wide-angle lens. So, but this works. I mean, the light from the top of the pyramid is hitting the back of the Sun. As I told you before, I had a vision of the back of the Sun. It was flat and dark. And so when the planets go behind the Sun, they're not as bright. They're using the ambient light of the Sun. but they're not as bright. Interesting too that when Venus goes in front of the sun or Mercury goes in front of the sun, obviously they get the crescent. Those are the only two planets that get a full crescent. But when they do get the crescent, that crescent is very bright, as opposed to when it goes behind the sun and there's no crescent, but it's fully illuminated, but it's dim. You have to wonder, why is that happening? Well, it's because the back of the sun is dark. That's why it's happening. The moon, I'm not sure if it's a full sphere. It wraps around. I think the moon also performs a function of containing the planets magnetically so they don't fall down too far, like Mars or Venus. When they go into retrograde like that, the moon kind of, like a gatekeeper. Hey, get back up there. Get back up again. So, but this is a working model. You understand just how, if you understand anything about fluid mechanics or magnetism, or orbital angular momentum, everything is being affected. All these planets are being affected by the sun and the gravitation and the lack thereof. I don't think you can find a working functional model in a heliocentric universe of retrograde motions. And they say it's just the apparent retrograde motion because the Earth is spinning, but I don't think you can find one. And if you do, it's really lame and horsey and campy. It doesn't make any sense. This is reality. This is the electric concave Earth universe. And it works. It works, guys. So this is revolutionary. I mean, pretty soon this is going to be the standard model. Just a matter of time. Because it makes sense. Earth is stationary. Celestial sphere is moving. The sun is moving. The moon is moving inside the Earth. However, we don't really have much time because I do believe the sun is going to stop pretty soon, and that will constitute the final day and the final hour. So, welcome to the new world. Welcome to reality. Ciao.